morning, good afternoon, good evening, everyone. This is the East Central and South Africa Microsoft Excel. It's brought to you by Crisp Excel Training and Consulting. And these are our partners. Today we are privileged to have Abdallah. Abdallah was here last year, and he's also agreed to come back. Abdallah is the next Excel MVP in the East Central and South Africa, and here are his areas of expertise. You can follow him on social media, especially on LinkedIn. He has very good content. Looking forward to his YouTube channel starting soon. Today, the topic of today is creating custom functions in Power Query. It's a bit advanced of topic, but I'm hoping everybody is going to learn from it. So, Abdallah, if you are there, I think you can start and then we continue.
Thank you, Crispo, for a nice introduction. So let us begin our session. I'm going to share my screen here. And I'm also going to turn off my camera. So, okay, thank you, Crispo. So to begin with, we are going to discuss first and foremost, what are the functions? Then we'll go to kinds of functions available in Power Query, then how to develop a custom function, and in the end, we'll discuss one of the very important concepts in programming called recursion. So we'll discuss recursion by developing our own custom recursive functions. So let us start. So what are the functions? In Power Query or in any other programming language, Power Query groups of code that are reusable. Reusable means you create it once, but you can use it several times. You can create a function and use it multiple times. That's the meaning of reusable, which is key here. And after the function executes, it returns a value. So the importance of using function, why should we use functions? Take, for example, you want to calculate, you have a program that calculates a square root of a number, and you are calculating the square root of a number maybe 4 times in your program code. So without using a function, you mean that the same implementation of the code that you're using to calculate a function of a number should be repeated 5 times. So taking advantage of function, you can create a function once and call it 5 times. Using a function is called calling a function. We call it calling a function means you use it a already created function. And some other use cases such as data transformation, data cleaning, and many multiple tasks that function helps. There are actually 2 kinds of functions in Power Query. We have those functions that are inbuilt. They come with Power Query already, like a function for splitting a text, which is text.split function, and the other text splitting function. There are so many. You can get an uppercase of a string using text.upper function, or a length of a string using text.length. All these are functions that comes with Power Query. They are also called pre-built or inbuilt functions. And they have key benefits that saves time. Instead of designing a function from scratch, you use it which is already given to you by Microsoft. So it's a time saving using the built-in function. But so why do we create our own function? Sometimes you may find that you have a task that requires you, actually you don't find any function that is inbuilt that will provide you with a solution. So you are forced to create your own function. But if that is not a case, the simplest way is to use the function that was already provided by Microsoft, the so-called pbuild function. This saves you time by leveraging the existing functionalities. So how do you create your own function? Creating your own function in Power Query is simple. You just say, for example, late. You can see the code here. You say late, the name of the function, you provide with the parameters, and between you find a late. In between here, you provide the logics, a number of steps that execute, and provide you the solution. This is just a framework, like a skeleton. It can be more simple than this. So let us discuss very important concept here. When you are designing function, you are required to provide 0 or more parameters. These variables that you find here inside a parenthesis, as I said, you start with the name of the function, like this one called custom function, equal sign, then you open parenthesis and close parenthesis. Inside parenthesis, you provide parameters. It can be 0 parameter. So what are the parameters? The parameters are the variables that when you want to use a function, you will provide them with values. When you are defining a function, you are defining or you are specifying your parameters. The parameters are also called variables. Then when you are using your function, you are calling your function. When you're calling a function, you are using values. Those values are sometimes called arguments. So these are 4 terminologies that you need to make sure that you understand, because they can be confusing. So parameters or variables, and arguments or values. So values for arguments and parameters for variables. So take for example here, you say this function will need 2 variables or parameters. Parameter 1, and it will be, for example, a type text. This will define a type here. Let's say parameter 1 is a text. We'll see when we go into writing the actual function. And the second parameter maybe is of type text. So assuming this function is trying to maybe calculate, it's trying maybe to get you the mid of the text. So you can use the mid function, and maybe this one is the starting position and this is the number of text. So you can use the mid function here by using this parameter at the first parameter in the mid function, etc. So let us go to practical examples. I have my function here that cleans the text. My cleaning is just a 2-step. First of all, I'm just lowering a text. I'm using the built-in function text.lower to make this text as a lowercase. Then the output of this, I'm using the text.trim to remove the leading and trailing spaces. So then I return the last value, which is no spaces text, as my final answer. So the clean text function return this one, no space, which is the last step. In the Power Query, we normally, but not necessarily, return the last step. We'll see when we go into writing code. Okay, so this function has 1 parameter, which is text, and it is of type text. How do we use a function? We can use a function, for example, when you want to transform column. There is a function in Power Query called table.transform columns. You take a source, which is the name of the table. Then you provide the name of the column that you want to transform, and a function that transforms that column. So you see each. Then we use our function that we've designed above, the clean text of underscore. So we discuss what is each and what is underscore in the upcoming slides. So let us discuss also the concept of default arguments. Sometimes you want to provide, you create a function that has maybe 2 or more parameters, and you want one parameter to be optional. That means when someone leaves it without entering any value, without providing a value or argument, then it assumes the certain value. Doing so, what you do is to use the optional keyword. You precede this parameter with an optional keyword. You say, for example, this is parameter 1 called arg1 is a number, then the optional parameter 2 is number. Then you come into actual code, you say if this argument 2, which is say optional, is equal to null, means it has not been provided, then let's say 2. So this function, for example, it calculates the root of a number. Root can be square root, cube root, fourth root. So I'm saying my function root takes 2 parameters, and the second parameter is optional. So what I'm doing is, if I don't provide a root like 2 for square root, 3 for cube root, then I will assume the value of 2, assuming that you want to calculate a square root. So that's how you do with optional values or optional arguments in Power Query. So let us come to Lambda function. Lambda function are functions that have no name. They call anonymous function, and are defined when they are used inside another higher level functions. We see into actual code. So let us discuss the very important each and underscore. In Power Query, most of the time, especially if you're using user interface, Power Query will route to you automatically each and something. So each, what does each and underscore represent in Power Query? Underscore represent that the current items that needs to be processed, and the each means it tells Power Query that this function operates on the current row or item in a list or a table. If it is a table, it will operate in the current row. If it is a list, it means it will operate in the current item. How do you use? So you can use each like this. So you are saying this is a list or transform function. You're saying list or transform my list, which is 1 up to 4. Then go one item to the other. Then for each item, take the item. So underscore here means the current item. So you will start with 1. So underscore will be 1. Then you will multiply by 2. Then the next iteration will be underscore will be 2. Then so this is a simplification. We'll see the longest form of this. Okay, another example with this. For example, if we're working with a table, the table has a field named age. You say each age, maybe you want to return all record with age greater than 30. You say each age greater than 30. So it means for each, and Microsoft provides a simplified way when you're using each to a record. Here you were supposed to write each underscore age. The meaning is underscore is a record. Go to this current record, which is underscore, then access a field called age. So you get value of the age in the current record. So here there is an underscore before age. So Microsoft allows you to simplify by removing it. When you're using each with a field, you can remove this underscore. We'll see when we write the code. So greater than 30. This is how you can use the each with underscore. When you use your function, a lambda function has multiple parameters, as we have already discussed about the parameters. So you don't use each. You define those variables or parameters. So the way you do is you say x comma y or any other variable. You can say a comma b, then x plus b. This is a simple function that just sums the two numbers. So you can use any variable names here, like x comma y, which is very popular. You can use p and q, you can use r and s, you can use m and v, m and u and v. So any variable name here can be used. So the idea to use each is when you are writing a very simple anonymous function, when there is only one parameter. If you have multiple parameters, it is expected that you use different variables and you will not be using each. Okay, so let us go to practice, then we come back to recursive function. Okay, so I'm practicing this using Excel, but you can do the same in Power Query for Power BI. So in Excel, Power Query can be accessed by going to data. So I'm going to open the blank query. So I'm going to get, and from other sources, blank query. Okay, so assuming that I want to create a function that calculate the root of a number, I'm going to call this name of the function as a root, or any name, but the name of function is better to be descriptive so that when someone sees, he or she will have an idea what is going to do with it. Then I'm going to advanced editor to open the code. So here I can call my function, maybe because this is a query step, I can call my function. Then this requires a root, requires a number, comma, and raised to. You can see when I write a number, this has a different color because this is a built-in. So I need to change, maybe call num, and power, let me call it raise. You can see I'm not saying as we come back later and discuss what are they. So you say comma greater than. This means that this function's name, my function, requires two parameters, num and raise, and the program that is going to execute to return a value is followed by this one here. So here I'm going to say, very simple. In Power Query there is number.power, so number.power, and I'm going to use num, then root. So because this is the root, I'm going to take this, a reciprocal of this. So I'm going to say 1 divided by raise. So when this is 2, 1 over 2, a half, number to the power of a half means square root. When this is 3, number to the power of 1 over 3 means cube root. That's the meaning of my function. Then I'm going to say, return my function here. Okay, that's how you do the name of a function, the parameter 1, parameter 2, then the calculation that you use to return a value. So I'm using number.power. Actually, this is supposed to be capital. Yes, number.power. I'm going to take number raised to the power of 1 over raise. Okay, so let us see this done. You can see when you are done, it opens up this window so that you can enter your parameter. Kindly notice this. The number says optional, raise says optional. Just come back here. When you define a function and your parameters, you are not explicitly saying here the type of this, then all these will become optional. But if you say, for example, you can see num optional, raise optional. So let me say as number, and here as number. What does these keywords mean? You are saying this function takes a number, but this number is of data type number. Power Query has a data type called number, and also arrays is of data type number. If you explicitly define the data type, let's come and see. Before saying okay, you can see we have num optional, raise optional. So when I say done, now you can see these are not optional. Okay, they are mandatory. The moment you define the data type, it becomes mandatory. Okay, so I can provide here number maybe 4, here 2. I can say invoke. You can see the square root of 4 is 2, which is equal to 2. So let me test with another number, square root of 16. I expect to get 4. Okay, you can see here. Let us come back to our function. Let us make this raise optional, okay? Because now when we don't enter a number in any of these, because they are mandatory, it will generate an error. Let us see the error. For example, I want the square root, I can say 16, then here 2. But if I don't put a raise here, invoke, you see, please specify a value. It forces me to specify a value because this is mandatory. So let us make this optional raise. To make this raise heavy optional argument, you can say optional. You say optional raise as number. Okay? But now we need to find a way. How does the Power Query understand this is optional? Okay, it is okay. It is optional. So how does which number does this function assume when this is not entered? So you write here. You will use a let when you want to create variables. When your function has a number of intermediate steps, you need to define variables, and defining a variables, you need to use a let keyword. You say let, for example, a be equal to, okay, for this case it's quite simple. We say if raise is equal to null, means it has not been provided, then to else raise, comma. The second step may be b, which is a final. You say you use your function, you say number dot power, like we used previously, number dot power num, comma 1 divided by raise. Then I already had this one, so let me remove it. Expand this one. I can just put this down here by pressing enter. So you define a step that will make sure that your raise is defined. Even though this is optional, but you need to specify if someone does not enter the option raise, which number should be assumed by Power Query. So you say, let us create a variable a that says if raise is null, means it has not been provided, then the value should be 2. Otherwise, if it has been provided, the value should be the value of the raise. Then the second step is calculation. So this is simply number.power, the number.raise. Then finally, you return the answer that function will return. You say in b, because the last step is b, which calculate the root of a number. So we say b. So my function now is ready. So let us test it. Done. You see now we have optional in the raise. Let us calculate the square root of 16. I'll put 16, then I will leave this so that Power Query takes 2 as a default value. We have already defined here that if we don't enter this raise, if raise is equal to null, then the value should be 2. Okay, done. So let's say 16, then put nothing here, then you will say invoke. Okay, let us come back. Let's just come back. I think we used the invoke function. Let's delete and delete this one. Let us examine this again. Okay, so the mistake was here. So now we were using directly the value provided by NAMA. We need to use this value that has been transformed here, because this is taking consideration when the value is null. So actually this mistake was here. So put A here. Why putting A here? Because this A takes into consideration that when this is not provided, then the value should be 2. So it is handling all the situation that this is not provided. So done. So now when we say 16 here, nothing here, invoke, okay, sorry, delete, root, sorry, it is not now. The optional is raise, so here is A. So A is the raise. So you are talking, Kisco?
Yes. After you have written num and you instead
Excuse
of num.
Me? Yeah.
I'm
Okay.
saying,
Here is num. Yeah. Here is num. So the mistake was here because the transformed value is an optional raise, so which is A. So we are changing here an A and not num. So let us pray that this time works. Yeah, then we get your value. So that is how you can simply define your function with default arguments. Okay, so there are a couple of ways to define a function. For example, you can see this one, root. Okay, the other way is, let us change this root, delete, come here to root, advanced. Then the other way is to not use a let. We can remove let, and we can remove the name function, and we can remove this. Okay, so we are saying, because when we're defining function like we previously defined, actually the name of the function is this name of the query step. So we can remove this name that we provided by just specifying the parameters and the value that the statement or expression that is evaluated to provide a value to the function. So this is acceptable, then done. We still have the same function, 16, maybe square root of 16, we get 4. We can come again by default cube root, but this, let us test other roots. Maybe the cube root of 8, we know it is 2. So because we want a cube root, we need to specify here 3. It will give us 2, you see. But if we want just a square root, maybe of 8, we need to, we can just leave this without specifying a number. Okay. Okay, let us progress. So let us come to, that is how you can define your own function in Power Query. Let us go to recursive function. In programming, there is a concept called recursion. And when we're defining a function of the recursive nature, the recursive nature means the function calls itself during execution. For example, one of the most popular example to explain a recursion is the calculation of a factorial of a number. Factorial of a number may be 3 is 3 times 2 times 1. It means 3 times one number less 2 times one number less 1. You go all the way up to 1. And other people say you go all the way up to 0, which is also acceptable. And I've used it here. So how do you define a recursive function? You say, for example, to calculate a factorial of a number, there are actually a built-in function. So this is just to explain the concept of recursive function designing. You say it will take a number and this is as a number. So this is another thing to add. This number is a data type of the parameter, and you are saying my function, the output of a function is of data type number. So these are parameters, can have a data type, and the output can have a different data type or the same data type. So we're saying the factorial function takes a number and it returns a value which is also a number. To begin with, you are saying the factorial, if n is equal to 0, the factorial of 0 is 1. Otherwise, if n is not equal to 0, take n times the factorial of n minus 1, one number less from n. So let us try this in Excel. Let's call this, let's create a new sources, other sources, blank query. Let me call this here. An advanced editor. I can leave it as a source, or maybe I can write anything here, maybe fact. So this function requires me to provide a number. I can say is number and returns. We're saying if num equals to 0, then return 1. Otherwise, return n times the fact. The same function, you are calling the same function. So I'm taking this, go up here, n minus 1. So this is how factorial works. So assuming we have here number 3, so it will check is 3 is equal to 0? No. So it will do 3 times factorial of 3 minus 1, which is 3 times factorial of 2. Then it will come back here again, it check n is equal to 0? No. So here we have 3 times factorial of 2, so it will be now 2 will come out, it will be 3 times 2 times factorial of 2 minus 1, which is 1. So it will be 3 times 2 times factorial of 1. It will come here again and check is num is equal to 0? No. Then it will say n, 1 will come out, it will be 3 times 2 times 1 times factorial of 1 minus 1, which is 0. It will come here again, the value of inside fact is checked here again and again repeatedly. It will check here, then now will be 0, so 1 minus 1 is 0. If it is 0, it will be 1, so it will be 3 times 2 times 1 times this one here, which is num is equal to 1 times it's 1. This one will be multiplied, then the program will complete execution. This is how recursion works. And here, because we are using this query step, we need to say at here. Let us try this one and see what it says. Fact. Okay, you can see the name n wasn't recognized. Sorry, here we need to say I'm used to using n, so this is not n, it is num. You are using this variable, and here is num. So we are saying num is equal to 0, then 1. Otherwise, num times factor of num minus 1. So done here. So in a sema, the num factor wasn't recognized. Why this? Because you are using a step here. You are using this one in the same step. If you use this one in the second step in Power Query, that will be identified and taken. But in the same step, you can't use it. If you want to use the same variable in the same step, you need to precede it with at. So this is why most of the time you will find recursive function being written this. And we'll see how to bypass this so that we don't write this at. So now we have our complete recursive function that calculates factorial. We say done. Now we can have factorial maybe of 5. We expect to get 120. Yes. Well, factorial maybe of 60, 720. Yes. So what does it do? Maybe factorial of 3 or of 4. We get 24. It goes through the same procedure that we just said here. So it starts maybe factorial of 4. It starts, is 4 equals to 0? No. So if it is no, it will go to the else part. So say 4 times add factorial of 4 minus 1. So it will be 4 times factorial of 3. Then 3 will be evaluated here again. 3 is not equal to 0, so it will be coming here. It will be 4 already outside here, times 3, then times the factorial of 3 minus 1, which is 2. So we'll have 4 times 3. So now we have 2. 2 is not equal to 0. Then it will be 4 times 3 times 2 times factorial of 1. 1 is not equal to 0. 4 times 3 times 2 times 1 times factorial of 0. 0 is equal to 0. Then this is 1. So 4 times 3 times 2 times 1, which is this value 20. Okay. Let's check the 4. Invoke. Okay, we get 24. Let me remove all these. Delete. Also delete this. Let us go to another exciting example when learning recursion, which is not so popular. The two popular examples that I see is the factorial and Fibonacci sequence, Fibonacci numbers. So today I've come with a different example, which is to check if the number is, if the string is palindrome. So I'm going to write is palindrome function using a normal, which is a simple way, and then I will use the recursion to demonstrate how recursion work. So let me create another. I can duplicate this one and call it is palindrome. Can I call it 1? Yes. So here, to check if a number is palindrome, I can write here palindrome maybe, or any other variable. It requires a string, maybe S to simplify, as text, returns, I can say here, my function return logical. Logical means true or false. So I expect to get a string and check, I want to check if this is palindrome. So the result will be true or false, which is logical. So let me use the simplest way is to say S is equal to text.reverse. There is a very simple function in Power Query that reverses the text. So it's text. Let me demonstrate the usage first. Yes. Let me check my solution equals to text.reverse. I want you to see text.reverse in action. Power Query. So let me return this one. So forget about my function. I want to just test text.reverse so that you can see it in action and see what we are going to achieve. So done. You can see text.reverse. It has reversed the Power Query. Now we have this this very annoying text here. You can say when you reverse this, you get Power Query. So that's the thing that we're checking to test if this text is palindrome or not. So let us delete this step, return our palindrome result. So we're checking is palindrome, remove this comma because we don't have any step after that. So given a string s, parameter s, which is a text, return the logical by checking if s is the same as the reverse of s. That's the meaning of palindrome. Okay. So we can check, you can see now have, let me check for mama. You can see this stands false, is palindrome. Say amma. This is palindrome because when you reverse this, it becomes the same word. So expect to get true here. You can see. So our palindrome function work. So let us design a palindrome function using recursion technique. Let me duplicate this. Call this palindrome is palindrome to recursion. Rec. Okay. Rec means recursion. Go to advanced editor. So we can say we have a string s. To check if this is palindrome, the technique is to say you are checking the length. If text.length, the length of the text s is less than 2. All texts that have length 1 or 0. Length 0 means an empty string is palindrome. Any text with a single character, any single character text is also palindrome. That's the meaning of this one. So we're checking if text length, the length of text is either an empty string which length is 0 or it has a single character, the length is 1, then true. It means return true, this is palindrome. Else you check the first character should be equal to last character. So we are saying text.start of s, number of character 1. So you are checking the first character is equal. So let me put it down here a bit. Is equal to text.end, the left, the right. This is equivalent to Excel's left function, and this is equivalent to Excel's right function. Text.end of s, 1. So the first character should be equal to the right character. Okay, the last character. That's the meaning of palindrome. The last should be equal to first. And the following characters also, second last should be second first. Second first. So, and also is palindrome when we remove these two texts, the first character and the last character. So let's say palindrome of, I can use text.mid, text.middle of text s. Where do I start? I start in the next character, which is the first position. This is the position. Power Query is position 0 based. So 1 means the second character. So you take a string, you go to the second character. You have already checked if the last two characters, the first character and the last character, are equal. So then you are checking, you are ignoring the first and the last. You want to check if the second character is also, if it is a palindrome. When you check for the same behavior here, the characters ignoring the first and the last. If you want to ignore the first and last character from S, we say text.middle static position 1. How do we go the length? We can say text.length of S minus 2. Minus 2 means you are removing 2 characters. When you're starting from the second position, and the length is the length of the original string, remove 2 characters, you will be ignoring the first and the last. This function here, it means you are taking second character all the way up to second from right of the string. Okay, if this is okay, let us test. I think it's the only thing we need to do. And here we need to say at. Don't forget to say at palindrome. Okay, so we are calling the same function again to test if it is palindrome, the text ignoring the first and the last. When the text is palindrome, the first character in the string is equal to the last character in the string, and the second left character is also equals to second right character, all the way until you find the text. The length is maybe 1 or 2, maybe 1 or empty. It may be an empty string or a 1 character string, depending if the original character is either even in length or odd in length. So let us go and test our function. This is only what you need to implement as a recursion. So let us test here. Mama false. Let us see also you can see we get true. We can also test an empty string by writing an empty string here. We expect it to be true. Why true? We can come here. We say when the text length is less than 2, it is a palindrome. So let us test this one. We get true. So our function, palindrome function, work using a recursion technique.
There's a question, Abdallah.
Okay.
There's somebody asking where can we use this logic in a business case?
Okay, in a business case, it depends. I think you can just search the use of recursion. It's not something that is very popular, but there are a number of things that you can achieve. Recursion is very broad. It can solve a lot of problems. For example, this one, maybe you might not have thought that we can achieve checking palindrome using recursion. So it might be very few application, but in real world there are those applications. We can just Google the application of palindrome. Sorry, application of recursion. You can definitely find many applications of recursion.
I was thinking also when calculating, maybe creating a function that calculates tax. It has to go through all the tax brackets and see which tax bracket that you are in.
Okay, so let us finish our presentation first. Then we can come back with some, maybe we can have those practical examples. Okay, so now I want to apply what we have learned to a real world task here. I have a data here. Let us see how we can edit, remove these. Okay. So let us see, we have our data here. We can define a function that calculate maybe, this is the population. We can calculate maybe a projected population. Let us see this. We can say in Power Query, in Excel, you can come to here data, click anywhere in your table or in Excel range, then you can come to the data tab. You see here, there is a table/range, or All options are here from other sources. You can come here from table/range, but there's a shortcut here from table/range. Okay, I normally delete this change type, remove this. Let us go to advanced editor. So let us define our function here that create a projected population. Maybe we have a data for, let me close. Our data has population, so let us create a very simple example that calculate maybe projected population given a percent projection. We can say maybe population proj. This requires a number, maybe call it pop as number, return as number. So return, you can see here equal and greater than needs to be together. If you put a space here and put here, then it will be a syntax error. So we need to say here, okay. So what I want, given a population, maybe and projection in percent, maybe in percent, I can calculate population projection by saying is equal to population times 100 plus this percent projection divided by 100. Very simple function. So you see, so you have your population, you want to project, maybe you want to get when the population is incremented by 10%, maybe you are providing number percent, but as in form of a number. So say as number, let's define the data type here, and also it will return, your function returns number. I want this to be a whole number, so I can use a built-in function number dot round up, this pop times, okay, that when you get a decimal number here, it is rounded to the nearest integer. Okay, so and let us use this function. So I can come here, I can use, let me call it result equals to, let me capitalize. I want to create, in this table, I want to add another column that say projected population, which uses this function. So I can use the table.add column, The original table is the source. I'm adding column in the table called source that we read the original table from here, from Excel. It is named source, this one here. In this table, I want to add a column. You provide the name of the new column is projected population, maybe projected pop. So let me use, I will say each. I'll come to this each. Then go to the field called population. I will show you. Let me use it first. Population, and use this function projected population. So I will say projected population, this field. Okay, let us try to understand here. So I'm adding a column called projected pop in a table called source using this function. So each means it will go to every record and take a field which is named population and put it inside a projected population project function to calculate a projected population. At this time, this function requires us to put, it has two parameters. One is back, which is pop, and the second is pop. So here, this is pop. Then we need to provide a projection. maybe 10% increment. Okay, so let's see, return this result. Let us come here. We can see after projecting our result, then the new population projected by adding this 10% of this is this one. Okay, so what if we want to make this optional? If we don't put this to be taken as 10, we can use the technique that we define. We can use let here. Let maybe a and equal to, and we need to say optional here. Optional. And if spec is equal to null, means it has not been provided, then take it as 10. Else take it as spec. If a is equal to if a assigned equal to, if spec is equal to null, then 10 as otherwise spec, comma, the second variable b that does the calculation. Okay, let me put here down, and b here down. So the first step is a, you say if this percentage is not provided, is null, then take it 10, otherwise take it as it is. So now we need to use this a, which is a PEC instead of PEC, because if we use PEC, it means when someone has not provided this, it will take null, which will bring it a null value. So we want it to have non-null value, which is defaulted to 10. So we say b not if is our calculation, which number dot around pop. Instead of pep, we put a. A is this one, which is clean version of this. Then lastly, we return the value of b, which is the last calculation. So we say here b. Press enter, then we say b. Okay, so our function is called population purge. It takes population and the optional percentage, all those as a number, then returns a number which is rounded. But first and foremost, this is optional. We need to say to check if it is null. If it is null, means it has not been provided. Then we say if it is null, then take 10, which is optional, which is default or default argument. Otherwise, take the percentage which has been given. So now here, instead of putting 10, we can remove this 10 and say done. You can see calculation also text is like the previous one, because it has searched for the value, no value provided here, then it gets 10. Otherwise, you can put maybe 20%. Okay, you can see the values are changing, be 50%, half. You can see the value, projected value. Okay, now let us come to understand this each. Okay, if you put comma here, you can see column generator is a function. So in a Power Query, if you see the option requires you to provide a function, so you are going to provide a lambda function, which each is most popular because it simplifies things, especially for example like this one, which does not require so many things. Then you can use the each, and we say each plays with underscore. Each means it's telling Power Query to calculate, to provide computation on row by row basis, because this is a table. If it is a list, on item by item basis, and this item is represented by underscore. So the current row here, which we are processing, is underscore. So we are required to put here underscore. Okay. Ideally, this is what it was supposed to be. We are supposed to put underscore here. If you come to here done, you can see it is still processing. Why? Because when you use each, it means it takes the current context. For example, the table.add column means you are playing on row by row basis, a record. So the current record, go each to the current record. So the current record, go to the field called projection, then use this function called population proj to process the current record under the feed population, access the value that has been stored here, and use the other parameter, which is % to process using the function process project. If you don't want to use each, you can use any other variable, but you need to say, you need to start with a parenthesis, maybe use variable x. So you can say this one equals to this one, like we used. So you are saying this now represents a record, because the table.add column you are playing with records. So this is a record. So in this record we need to say, what if I don't put underscore, or I leave this as when I use the each? When I use each, you can ignore this underscore and it will still work. So let us test now. We are using other variable other than each. We are not using each. Then let us see done. You can see it returns an error. What you need to do, if you are not using each, you need to say, because this is a record, come here and say, this record called x, get the feed value or code population. So now this is working. You can see, that's why. Alternatively, if you want to use this, you can say underscore. Then it will still be taken like each. If you use variable called underscore, this underscore placeholder, this is equivalent to saying each. Now we can just ignore this part, or we can put underscore here, go to the record called underscore, which is the current record, access the population field, and put inside the population project and compute the projected population. So now this works, you can see. Or we can also remove, like we used when we use the each, you can remove this underscore. It will still work. But if you use any other variable other than the underscore, like x maybe, you need to say here x. So record x, go to this record, take the value in the feed population, then compute the population projection. Okay? Yeah. So the last thing before I invite the question is about the art. We have seen here we were using art when we are working with recursion, for example, factorial. We are using art. Why? We are using art because we have defined the name inside a let function. Alternatively, you can remove this let and you can remove the name here, all. Okay. Then you can say you can use the query step, which is now the name of function. So factorial. You can say no, you are defining this outside let, but you are saying you are starting with a parameter. So this is a name of function, parameters, then a recursive call, then you are calling this factorial. Let's see this. Factorial of 5, 120. So we are able to bypass the use of art here if we are not defining our function inside a let, and also we are not putting a named step here. So we are directly using the function name, which is equivalent to this query step. So in that situation, you can just ignore this art. But in most of the time, if this is inside a let function, then you need to put art here to tell Power Query that this is referenced from this name in the same step. Okay, Crispo, I think. we are done. There are a lot of information here I've put in this presentation, so you can go through. Yeah.
Yeah, that was interesting, although a bit advanced for many people. Let me see the question. The question that if you have a question, you can raise your hands. I will unmute you. But there was that question that was asked on where we can use the recursion in a business case. So I don't know whether you have an example of where we can use a recursion in a business case.
For me, no, I've not have any real-world application. But because recursion is a very well-known programming concept, it means it has a number of applications. Yeah, one can easily Google search, and I think he or she will be able to find the example. So unfortunately today, I've not prepared the example. I've not gone through examples, real-world examples of applying recursion.
Okay, I'm thinking of a place where you have like tax buds or something, where you need to go and check, is this person in this tax bracket? If not, go to the next tax bracket or something like that. But I think the most important thing is to know how to do recursions. Is there any person with a question before we end? That was interesting, but I think even I need to rewatch the webinar again to get the gist of it. Anyone with a question? You can type or you can raise your hand. If there's no question, maybe I have a question for you, but now this is on more of how did you get good in Power Query? Is there like steps that you have followed for you to be this advanced? And what would you require? What would you tell somebody who is starting anew in Power Query? What steps should they do?
Okay, so for me is practicing more, and those Excel BI challenges are helping me. I started being serious with Power Query, writing custom code in I think in May this year. So like 5 or 4 months ago, I used to do just like clicking the user interface. So now I can write a complete program without using the interface. Let me search this guy for those who are viewing here now. Excel BI, Excel. This guy is called Excel BI Vijay Vema. You can check this. He's posting Excel challenges every day. So the thing that has helped me is to attempt this challenge, and you can see I'm very active. I rarely miss posting my solution here. For example, today, because I was preparing for this, I haven't posted my solution, but soon after this session, I'll take a look at what has been posted today. You can see here, yesterday I posted my 2 solutions. One is of this, you can see, a bit complicated for beginner, but it's very easy if you know what does it mean. So I think not only Power Query, if you want to be good in programming, you need to practice more. And if you get this platform, for example, attempting challenge from this guy, it will make your knowledge, it will cement your understanding of the programming concepts.
Okay. I can see you're also good in Python, which is new in Excel. Is it something that you'd like to come and present later in another day, like how to start with Python for those people who are starting?
Yeah. I'm open to that. Let us see how we can arrange on that.
Okay.
Yeah.
Okay.
Python basics for data analysis is very simple. So we can just have a session here. And one thing, let me show one thing here. Maybe you have your function here, you want it to be used by other people, so you can send them this file, or you can say if given there is another file, maybe this one here. This file has the same data but does not have these functions. You can come here, data, sorry, not recent, data, queries and connection. Then you can easily come here, maybe copy your query, copy, come to the function, to the file that does not have that function, then you just paste. Then you can see automatically the function is pasted and can be used in this workbook. Yeah.
Okay,
This
I
I
didn't
think
know that.
the easiest way.
Okay, and is there a way that you can share, like in an organization, you create a function in one workbook, and every other person in that organization can be able to access it?
I'm not sure about that. I think this
Okay.
is the only way I know is you can share this. You can develop
Okay.
your functions and share the file containing variable functions so that people can access.
Okay.
Yeah.
Okay. I think that's it for me. A few comments on somebody wants me to share the content. Yes, Abdallah will send me and I'll share the recording and the workbook that he was using. Alan is saying he joined late, but you are an inspiration to him.
Thank you for that.
Yeah, what you do, I think, doesn't go unnoticed. You are helping a lot of people on LinkedIn and everywhere else. So keep it up. Jose is also saying thanks, Abdallah. He didn't know that you can paste the code too like that. So well done. Oh, Alan is also asking, do you provide one-on-one coaching? Maybe that's something that you need to say. If somebody wants to be taught, do you train? Do you have like a website where you have created a course people can follow? How do you help people who wants more personalized training?
Okay, actually here in Tanzania, I'm providing training, but they are all in Swahili, training in Excel, in Power Query, Power BI. I have those training in Python. So I'm actually providing training using online training like this. So if you want training, you can just check with me, especially for future offering that I normally advertise. Yeah.
What about the people who do not understand Swahili? Do you have some that you have recorded in English or something? I don't know whether Alan understands Swahili or something.
Yeah, I have few videos in English. I've started posting my video clips in English, so keep in touch with me. But no a full course maybe in Excel or Power Query that I have recorded in English, even in Swahili. Yeah.
Okay. Maybe something to consider for the people who are requesting. So Alan, I would urge you to connect with Abdallah on LinkedIn. Maybe you can continue the conversation there. And I'm pretty sure he is more than willing to do one-on-one coaching or even consultancy on whatever you want. Yeah. Okay, thank you, Abdallah, for coming again, and we hope to see you again when we are doing Python. And I think that's it. That's the end of the webinar. Thank you for coming.
Thank you everyone for coming. Thank you so much.
Okay, bye.